Exercise C6. Linear and nonlinear relations. 1. Use first differences to decide if the relation is represented better by a line of best fit or a curve of best fit. So quickly check to make sure the x values are in order. Then we calculate the first differences. Take row 2 minus row 1. 11 minus 5 is 6. Row 3 minus row 2. 17 minus 11, 6. And you find out all the first differences are 6. They're constant. It shows a linear relationship, so you can use a line of best fit. B. We have x values from 1 to 5 in order. Y values are here. First differences. So you start subtracting 40 by 80. It's negative 40. 20 minus 40, negative 20. 10 minus 20, negative 10. 5 minus 10, negative 5. The first differences are not the same. Therefore, you have a nonlinear relation. So it will be better represented by a curve of best fit. Number 2. The pattern was constructed using square tiles. Frame 1 has 1 row, 2 columns. Frame 2, 2 rows, 3 columns, area 6. Frame 3, 3 rows, 4 columns. 3 times 4 is 12. How about frame 4? Well, it looks like the number of rows matches with the frame number. So we will have 4 rows and 5 columns. 4 times 5 is 20. Frame 5, 5 rows, 6 columns. 5 times 6 is 30. First differences. 6 minus 2 is 4. 12 minus 6 is 6. 20 minus 12 is 8. 30 minus 20 is 10. So is this a linear relationship? No. The frame number and areas are not related linearly because they have different first differences. Show the information on the graph. So frame number 1, 2 units. Frame number 2, 6 units, and so on. These points, they form a curve. So this supports your answer in B. Question 3. Here's a pattern constructed using square tiles. Frame 1 looks like this. Frame 2 has 2 extra tiles, so there are 3 tiles in total. Frame 3, compared to frame 2, has 2 more tiles, so there are 5 tiles. If we complete the table of values for frame numbers 1 to 5, there will be 1, 3, plus 2, 5, plus 2, 7, plus 2, 9 tiles. The first differences shows constantly a 2. Is this a linear relationship? For sure, because we have constant first difference. Graph the number of tiles against frame number. Does the graph support your answer in B? So, frame 1, 1 tile. Frame 2, 3 tiles, and so on. The points line up on the straight line. Therefore, it does support our conclusion in part B. How many tiles will there be in the 9th frame? We keep adding 2. We can do that. Or we may figure out, well, I have 5 times 2, which is 10, minus 1 is 9. 4 times 2, 8, minus 1 is 7. 3 times 2, minus 1, 5, and so on. So that's a relationship between frame numbers and number of tiles. You multiply 9, the frame number, by 2, 18, take away 1, which is 17 tiles. Number 4. A barrel contained 42 liters of water. So barrel is a huge container usually made out of wood, sometimes plastic. The water was leaking out. The table shows how the volume of water in the barrel changed every hour. So we have time, 0 hours to 4 hours, volume from 42 to 38 to 34 to 30 to 26. So determine the first differences. So 38 subtract 42 is -4. And if you do that for every row, you get the same first difference of -4. This number shows that the volume of water goes down by 4 liters every hour. Is the relationship linear or nonlinear? Because we have constant first differences, this is a linear relation. How much water would be in the barrel after 6 hours? So in 5 hours, we go 26 minus 4. For 6 hours, we take away another 4. So 26 minus 4 minus 4 is 18 liters. When we make this calculation, we have to assume that the flow rate is steady, or you can say something like, we assume that for each hour, the volume goes down by, or still goes down by 4 liters. Question 5. Laura's swimming lengths to prepare for a triathlon. The table shows the distances she swims in meters. A. By how much are the numbers in the first column increasing? So we go from 0 to 5 to 10 to 15 to 20. We're going up by 5. B. Determine the first differences. What do the first differences represent? So we have to use the distance column. So 125 minus 0 is 125. 250 minus 125, 125. If you keep doing that, you'll notice the first difference is always 125 meters. It's a positive number, so this represents the distance increases by 125 meters for every 5 lengths. Is this relationship linear or nonlinear? This is a linear relationship because we have constant first difference. D. Graph the relationship on decimals. Does the graph support your answer? So let's take out decimals. And we can create a table of values in decimals by clicking on the plus button and then calling out on the table and then enter the information on it, just like the table that I have shown you below here, and so on here. So I'll enter 2 points, so you see how these points get there. Okay, and then we can see that these data points from this question form a straight line. Therefore, we can say that yes, the graph does support a linear relationship conclusion. And E, what is the length of the pool? How did you find out? Well, it looks like every 5 lengths that Laura swam, she completes 125 meters. So for each length, it's like unit rates, total distance divided by the number of lengths that happens. So 125 divided by 5, that's 25 meters. So every 5 lengths is 125 meters, so divide that to get 25 meters per length. Number 6. Multiple choice question. Adam works as a store associate. The table of values shows his annual salary in the last 5 years. So here it is. Salary is going up. If the trend continues, what will Adam's annual salary be in year 7? Well, to study the trend, the easiest thing for us to do is to figure out how much increase does he get every year. So from $30,000 to $32,100 is an increase of $2,100 or $2,100. Do the same thing. So 34,200 minus 32,100, you get 2,100. So it keeps going like that. So the table ends in year 5. So we have year 6, then year 7. So 2 more rows to go. And assuming that the trend continues, that means we can take Adam's salary in year 5, $38,400, and add $2,100 twice. So 2 times $2,100, which gives us $42,600.